In this lecture today, we will start discussions on a new knowledge representation scheme that is called frames. Till now, we have looked into other two very important knowledge representation schemes. One is rules, which is also known as production rules, and based on production rules, we have seen rule based systems, and we have also seen how the inferencing is done in rule based systems. Secondly, we have seen semantic nets as a very fundamental knowledge representation method, and in the last two lectures we have also looked into the inferencing method that is adopted in the case of semantic nets. Today we will be discussing another knowledge representation scheme, which is a little more systematic, but fundamentally it has got many concepts in common with that of semantic nets. And this knowledge representation scheme that we will be discussing today is known as frames. Frames, or the systems which are based on these frames, are known as frame based systems. This system was propounded, was proposed by a famous computer scientist and artificial intelligence researcher, Marvin Minsky, and he proposed this scheme in order to represent common sense reasoning. If you have noted, in case of rules, we have to enumerate all the possibilities to describe a particular state of affairs in its antecedent, and if they match, then it will fire the rule and the actions corresponding to the consequent will be taken. However, this rule based system is also known as production rules, and one school of thought stated that this is the way the human beings represent their knowledge and they take rule based decisions. However, Marvin Minsky and other AI research decisions by our common sense. Do we really always fire the rules and match all the antecedents in order to see which rule is applicable in a particular scenario? That was appearing very unnatural to them, and so they thought of an alternative knowledge representation mechanism, and consequently the frame system was proposed. Now, what is a frame? A frame, let us first look at the definition. A frame is a prototype of a concept. A very important point over here is prototype. All right. A prototype, it is not the exact description of the concept. We will see what we mean by the prototype. It is basically the schema, the structure, okay, of a particular concept, and what are there? It denotes the attributes of the concept. Every concept that we talk of, for example, if we take the concept ball, if we take the concept ball, now there are so many attributes that we can specify about the ball. Maybe its color, its shape, its size or the diameter, maybe the weight, etc., so on and so forth. Now, this shape, in order to be a ball, will be obviously spherical or round. All right. Maybe the material, whether it is a cricket ball or whether it is a football, whatever. So, these are the different attributes that are associated with this concept ball. Now, obviously, you can see one of these attributes, like while the other attributes can vary, one of the attributes like the shape has to be round in order to be qualified as a ball. Okay. So, that is a particular importance that this attribute shape has. But right now, these issues we will be discussing later. Right now, I would like to elucidate what concept. Now, I note another thing, that I am not talking of a particular ball. This is the concept ball. I can have 10 different balls, maybe 5 footballs, 2 cricket balls, etc. But those are different instances of the same concept. Similarly, we can define a particular concept like bird. Say, if I define a concept bird, then I think you can start thinking of the different attributes of the bird, maybe the type or the name of the bird. Now, you see, when I say the name of the bird, I am not talking of the particular name that I can give to my pet bird, but I am talking of a particular species of the bird, like say maybe sparrow. Similarly, there can be the color of the bird, the size of the bird, okay, so and so forth. Now, these are the attributes. Okay. Another attribute is, can it fly? Now, you can wonder that why should all birds fly, but that is not the case. For example, ostrich is a bird that does not fly. So, can it fly can have an answer yes, no. The color can be blue, can be yellow, the name can be sparrow, can be parrot, all right. Now, you see the ones that I am now putting in this rectangle, these are the attributes of this particular concept. And the other ones which I am underlying now are the different values. Say yes, all these things are. So, similarly, size can be any real number. So, these are the values, but we are now considering the attributes. So, if I want to describe the concept bird, then that particular concept has associated with it a number of attributes, all right. So, now let us go back to this description. A frame is a prototype of a concept which will describe the attributes of the concept, and by that I mean the class of objects or concepts to which the concept in question belongs, all right. One thing that I have not said till now, and some more things. Now, what do we mean by this? The class of objects or concepts to which the concept in question belongs. Say, I again take the concept bird, or say I take the concept, all right, say the boy. Now, boy is a concept. It has got a number of attributes, which we have already given some examples of. Now, besides this, the boy, suppose there are there is a class called human beings. Now, boy is a human being, right? Similarly, girl is another concept which has got a set of attributes of itself, but this is again related to another class, another category, human beings. Now, all boys are human beings, all girls are human beings, maybe all men are human beings, or all mothers are human beings, and mothers have got their specific attribute. In order to call a lady that she is a mother, obviously we look at some attributes, right? And again, mother is a human being. Now, what is important over here is that if I think of this human being to be a class, then the concept boy is a subclass of this class boy, this class human. So, here is a superclass and these are subclasses of the superclass. Okay. So, not only but also denote its class relationship, that it is related to which superclass, it belongs to which superclass. So, if we just take a set theoretic view of the whole thing, then we can also say that, say, human beings is a superset here, and boy belongs to that set, any boy will belong to that set. So, this class boy is belonging to this set. Girl is another concept which is a subclass of the class human beings, or all the girls are subset of this class human beings as well. Okay. So, that is what is meant over here, the class of objects or concepts to which the concept in question belongs. The concept in question in our discussion was a boy or a girl, okay, and the class of objects or concepts like human being to which this concept belongs, and we will see that there are some more things. The next important thing that we would like to define is an instance. Now, it is very important that we must be able to differentiate between an instance and a frame, instance of a frame and a frame, or instance of a class or the class. Now, I will be using these terms class and instance versus frame and instance of a frame interchangeably, because this has got a very close relationship with the object oriented definitions that we are using presently, which is very popular nowadays in different design domains and also in programming languages. An instance of a frame is a representation of a specific object, a particular object, all right, and that is the instantiation of a frame. Now, let us look at this. Say, let us take this example. Fido is a dog. Look at these white ones and the yellow ones. Fido is a particular dog and dog is a concept. So, we have got the concept dog and Fido is a particular dog, all right. Now, so Fido is an instance of the class dog. Now, again we can look at it in the way we are drawing. For example, now I am making a hierarchy. Animals, all right. Now, animals, this is a class, and animals can be mammals or those who are not mammals. Mammals, and dog is a mammal. So, all these arcs I can say dog is a mammal, all mammals are animals. So, any mammal is a animal. So, I think you are familiar with this relation is a, because we have very frequently used this in the case of semantic nets. Now, if we would like to again represent this, okay, before that, so dog is a class because I am not talking of any particular dog, all right. Mammals is a superclass of dog because dog is a mammal. Similarly, cat is a mammal. So, cat is also a mammal. So, that is another class. So, it is a superclass of dog, cat, etc. And animals, it is a superclass of mammals. All right. Therefore, so animals, so there can be different animals and some of them are mammals, and again among different mammals there may be dogs, cats and other things. There is a subcategory which is a dog, because there are some attributes which really distinguish a dog from a cat. Okay? And if we say Fido is a particular dog, that is, I am talking of a particular dog and there may be other dogs also which are all dogs, say maybe Jimmy is another dog, all right. You see, I could have made a further classification of these, like you can say that I can further break this up by doing it like this, that dog, mammal, then comes dog, and then among them I can say Spaniards. Now, what is a Spaniard? Spaniard is a class, it is a subclass of dog. The Spaniards are subclass of dog, right. So, this is again a class. Now, if I say Jimmy is a Spaniard, then Jimmy is an instance of, it is an instance of relationship, all right, instance of a Spaniard. So, in that way, so it is a class, and all the Spaniard is also a dog. Now, when we are talking of Jimmy, then I am talking of a particular element of this class. So, the same thing we can draw in the form of a set. Say the largest set is animal. In this, there is a subset which is mammal, in which there are dogs or dog, there may be cats, and there can be Spaniards and all those. Now, when I talk of Jimmy, I talk of Fido, they are different elements of this set. So, in terms of the set theoretic notation, you can understand that each of these elements are particular instances of a class, and that class or the particular set. Now, anything that belongs to this set obviously belongs to this set. Or if I say dog, and Jimmy is an instance of dog, and dog is a mammal. Now, this is a easy relation, this is an instance relationship, and this is a easy relationship, right. So, Jimmy is an instance of dog, and dog being a mammal, Jimmy is also a mammal. So, this is a transitive relation. Okay. So, I hope now you have understood the difference between an instance and a frame, instance of a class and the class itself. Now, by frame we will be denoting the class, and by instances of the frame will denote the instances. So, now we can give you some quick examples, but before that let us see how can we represent the concept or notion of the creature dog. So, look at this. The description of a frame is very much like the structure data type that we use in the language C. So, you see, a frame consists of a number of slots. Each of these attributes, a dog is a concept which has got a number of attributes. What are these attributes? Number of legs, type of teeth, has tail, color of skin, owner, etc. Okay. Now, these slots can have values, and the values can be of different types. So, I represent the frame or the concept, the frame representing the concept dog as a set of attributes. Okay. Look, it reads a dog is a mammal. That means it is saying that is a dog, the concept dog is connected to the concept mammal, or the class dog is connected to the class mammal through the is a relationship which we are showing. Besides, there are these attributes like number of legs, type of teeth, has tail, color of skin, owner, etc. Now, you see, these are the slot names, and these slots can have values which are called the slot values. You may also note that the different values that these slots can have are not all of the same type. For example, dog is a mammal. So, this is a string, that is a class name. Number of legs, it is an integer. Type of teeth is again a string. Has tail is a boolean, yes or no. Color of skin will again be a string, owner will be a string, and there can be owner of the dog, can be a string. Now, here you see, this is a very important point. Look at this attribute, has tail. Now, when we are describing dog, we are saying, what does this mean? Dogs, the frame dog, its slot has tail, has a value yes. What does it mean? It means dog has tail. But obviously, there can be dogs which have got their tails cut. We often see such dogs at different places, right. Then is it the case that all dogs have tails? Here, what we are saying is this value is a special type of value which is known as a default value, which we will discuss just soon after. That is, unless we know that the tail of the dog has been chopped off, we can safely assume, and we in our common sense we assume that if it is a dog, then obviously it has a tail. So, through this description, I really build up the concept of a dog, and I need not fire 10 rules in order to infer that a dog has a tail. The notion of frame is that it is hypothesized, it is felt by some people that we have different, when we learn different concepts, along with that we also learn the attributes of the concept and the different values of those attributes. Okay? So, we also, unless we know something different, we have seen so many dogs from our childhood. So, and we have learned from our science, basic science books, that dog is a mammal. We have seen and learned that number of legs 4. So, as soon as the word dog is uttered, all these things are activated in our mind. Okay. Now, this owner, I could not put a value over here, because dogs may have owners, except for street dogs might be. But for the concept dog, there is no particular owner that is tied to it, right. For a particular dog, it may have some owner. All right. Now, we again describe Fido. Now, what is Fido here? Fido is a particular dog. Therefore, Fido is an instance of the concept dog. So, let us see how the values, slot values have changed. Fido is a dog. So, I could have written here also Fido is instance of dog, that would have been more correct. Now, number of legs 4, because Fido is a dog, so it has got number of legs 4, type of teeth sharp, has tail yes, color of skin black, owner here, owner I can put the value Rahim. And even earlier also the color of skin was blank, because I cannot attach any particular value to the color of skin of the concept dog. Okay. Now, you see here now when I describe this, that is automatic. So, is a concept and dog is a mammal. All right. And dog had attributes like type of teeth, it was, the value was sharp. I would not use the, so the value of teeth is sharp, number of legs 4, color of skin I did not put any value, owner I did not put any value. Okay. Now, I say, I select another color, say I say that Fido is an instance of dog. Now, when I say this, automatically I specify many things without specifying them with Fido. Here I need not, I do not need to specify that Fido has 4 legs, Fido's teeth is sharp, okay, because since Fido is an instance of dog, some of these attributes which are specified will automatically be inherited in the instance. You are familiar with this term inheritance through our discussion on semantic nets. Attributes which are not specified in the class definition will be, so these are automatic. So, these attributes like teeth, number of legs, these are automatically inherited from here from the class definition, I need not specify it. Those attributes like owner which is not specified in the parent class, or the color of skin which was not specified in the parent class, can be specified here. I can say it is black and owner may be Rahim. Now, this is the advantage, one very important advantage of frames, and this advantage is derived from the inheritance that we have just now shown, and this is known as, this advantage is a very important advantage for any knowledge representation, is the economy of representation. When if I can infer many things and yet I need not need not explicitly specify it all the time, then obviously it is an advantage. And that is, I am specifying less, but I can infer more. That is the economy of representation, and that is always attractive. Okay. So, you see that all these need not be specified, but they are inherited automatically, and I can build up a C structure like this with these values. Any slot value, any slot which is not, which does not have a value, or we say that the slot is not instantiated. That means, this slot has not got a particular value as yet, we will infer that to be unknown. Okay. Now, we come to a common notion which we have seen earlier, that is the concept of object attribute value. We have, while discussing about rule based system and also while discussing about semantic nets, we had mentioned that many facts of the real life we can represent using this object attribute value triple. Okay. So, an instance of a frame is denoting an object like a dog. The slots are denoting the attributes of the object, and the slots can be of different types as we have seen, and the slots are instantiated with values. So, if we go up here, you see, if I just make a statement, Fido is a dog, and that is automatic here, it is represented here because the object name is Fido, attribute name is a, and the value is dog. So, you can also see how it equivalently translates into a proposition. Say if I take this object or instance and take this attribute and take this value, what would be the equivalent proposition? Can you tell? That is, if I write in our well known proposition logic, we would say number of legs of Fido is 4, right. So, you see that every object and we have seen that the slots can be of different types and the slots are instantiated with values. Now, let us quickly look at a correlation between semantic nets and frames. Here is a semantic net that we had shown earlier in the last lecture. Nelly, now in semantic net we draw like this, everything is like oval. So, Nelly is a elephant, elephant is a animal, animal, here look at this dotted edge. In semantic nets we draw everything in the same way. Animal, I have intentionally not written these attributes because I wish and hope that you will be able to say what this attribute is. Animal and head, how are they related? I can say animal has part head, elephant and Africa. How are they related? They are related with elephant found at or lives in Africa. And Nelly is a elephant, elephant is an animal. Now, if this information, suppose I label these ages, if this information is to be translated into frames, then what would be the class, what would be the instance? Now, please note it down, because based on this we will be now drawing the frame, or we will just show what the slots are. Now, if I look at elephant, it is a class, all right. So, elephant is a what? Elephant is a, according to this semantic net, animal. So, this is a class relationship, all right. And there are other attributes, and also elephant found in Africa, all right. Elephant again has part head, all right. Now, you see I have intentionally used two different colors. So, here you see the class is the name of the instance, the class is denoted by the frame name. The relations of the semantic net are actually the slot names, and we have got the slot values, all right. So, if we have Nelly, which is an instance, Nelly, we will say it is an instance of elephant, all right, and other attributes. Now, so if we go back here, you see that the concepts are translating to either the frame or the instance of a frame. Nelly is an instance, and the relations are translating to the slot names, and we are putting in the slot values. Now, this distinction was not there in the case of semantic nets. So, we can now say that what are slots? Slots denote attributes. Attributes are typed because there can be different types. Some values are defined in the frame definition, already instantiated, like we have seen that in the case of Fido and the dog, that some are already known, some values are defined in the instances only. Instantiated slots are defining facts or propositions, which you have seen, and this may be used to answer queries. Now, this part I would like to mention. Say, if I look at this instance, then I can answer the query. If the question is put, does Fido have a tail? The answer will be, I will come to Fido, I will go to the has tail slot, and I look at the value. If there is no value, I will say unknown. Okay. If there is a value, I will say yes. Who is the owner of Fido? Fido. Who is the owner of Fido? So, I look at the object. What is the object? Fido. And what is the attribute I am questioning? Owner. So, I come to this owner slot, and what is the value of that here? So, it is Rahim, and so my answer to the question is that the owner of Fido is Rahim. So, this instances or this representation helps us to answer queries. Next, let us ask the question, what are there in a slot? Obviously, in a slot there will be values, there will be types which will say what type of, and here I am introducing two new things which you do not know, that is constraints over possible values. I cannot allow any value, not only type, there may be a range beyond which I cannot put in the value. We will see examples of that. Also, we put in some predicates. Now, these predicates are also known as daemons, or they are actually functions. If you compare it with object oriented systems, let us have a quick comparison with object oriented systems. Those of you that there are concepts of classes and objects of a class. Now, if I make a mapping, then I can say in an object oriented system, and side by side I look at frame based system. So, I have got classes in object oriented systems and they are mapping to frames. This is a mapping. I have got objects in object oriented system and that is mapping to instances in the case of object oriented systems. Over and above that, those of you are familiar with object oriented system, the objects communicate using messages, okay, and when an object receives a message, then it fires or it activates some methods. These methods are equivalent to these daemons, all right, or these are also used as predicates. Okay. So, there is a one-to-one correspondence between these. Okay, that will, okay. So, slots can be, now this is another point, slots can be structured or there can be frames within a particular slot, and how do we denote that? We will show with an example that we can use pointers to another frame. Let us look at this example. Now, boy is a human being. So, Isa is a slot name, human being is a value, name is a string. Now, you see here for a boy the name part is not instantiated, but the type is specified that whatever values it may have should be a string. Age will be an integer. Now, you see here, in order that I can really call somebody a boy, the age must be less than equal to 15. Height, type is a float and height should be less than 7. Otherwise, that is a spurious or wrong value that is coming. Stays at, I am sorry, this stays at int, is it all right? No. Stays at, it should, okay. Studies in will be string. There are no constraints put over here. Grades, now here you see type is a pointer to results. So, results is another frame. Now, that means what? That if I need grades or the CGPA, then for that boy there is a grade, the grade can be computed from the results. Whatever marks he has got, based on that I can find out whether he gets an A or B or C. So, it is a pointer and pointer to another frame which is known as results. That is also possible. That is what is meant by this last line. Slots can be structured, that means within a slot I can have a frame. The next thing is, in addition to these types, I can put in predicates. Now, what are these predicates? There are two types of predicates, if added and if needed. I will come back to this in a second. Now, there are two types of predicates in general, if needed and if added. If needed predicates state how to find or compute a value. So, if you need a particular value to be computed for some inference, you will have to, that particular predicate will tell you how you can compute it. And if added predicates are used to check the constraints on the values, that can be used for consistency checking also. So, you see, if I need grades, here is along with this slot I have put in a predicate if needed, that is if at any particular point of time I need this for inference, I will fire this function, I will activate this function, compute CGPA with maybe the parameter boy and results, because I will go to that result frame and will compute the parameter, compute the CGPA. Suppose from some other inferencing I get the value of height and the height is 7.5 feet. That will violate the constraint that has been put in, because if some value is put in, I want to check whether it is a correct value or not. So, I have got a constraint here. So, if the height is added, then I have to check this constraint, all right. Now, let us look at Tom. Tom is again an instance of boy, name is Tom Smith, age is 12, see all these things are instantiated, height is 5, stays at say 15 Park Avenue, studies in Bright Academy, grades. Now, grades I will say if needed compute the CGPA of Tom from results of Tom. Okay. So, let us quickly recapitulate what we have said. In a slot we have got the slot names, along with every slot we have got its type. We have got some constraints. The slots can be instantiated with values. We can have constraints with the slots. Also, we can have predicates with the slots. Two types of predicates, if needed and if added. If needed predicates are very much, you will see how they are used for inferencing. Okay. Now, before going to the inferencing, we will quickly talk about two types of values. There are some things called generic values. Generic values are values which Tom drink milk. Can we get the answer from this description of Tom? No, there is no slot of Tom. But how we carry on inferencing? Say I have got a question, does Tom drink milk? I do not find any attribute about drinking over here, but I know I tried instance of. So, what would I do? Now, say I have got an instance Tom, all right. Now, here I am putting in the inferencing part also. Now, Tom has got so many attributes, but drinking milk is not there. But I know Tom is an instance of boy, all right. Now, I can go to boy and see if there are some attributes which are talking about some drinking. Now, unfortunately, in the description of boy that we had shown, there was no such attribute. So, we go up and we find that boy is a maybe human being, and human beings drink milk because they are mammal, drink say milk. Now, all human beings drink milk, all human beings drink milk because they are mammals. So, this is a generic value to this of this class, generic property of this class. Therefore, so any property that is holding for all elements of this class is known as a generic property. So, although we do not know whether Tom drinks milk, I will try, the inference machine will try whether, since Tom is an instance of a boy, whether boy drinks milk No, the answer is not there. So, I go up here and see that human beings, boy is a human being and human being drinks milk. Now, this information is true for all human beings. So, that is a generic value, all right. Now, so what is the generic value? The generic value, Tom is an instance of a boy, also boy is a human being. In the description of human being, we may have human beings drink milk. So, since all human beings drink milk, the answer can therefore be inherited and inferred through inheritance. This we have also seen for semantic nets. I hope this is clear. Generic values are the values which will hold true for all subclasses. Okay. Next, now similarly you can try Tom has a pen, does he need ink? Suppose Tom has a pen, does he need ink? Now, how do you answer that? Now, in the description of Tom, it is not there that Tom needs ink, but it is just said that Tom has a pen. So, we can therefore go to the class pen and find out that pen needs ink. Therefore, we inherit the answer down the line and we infer that Tom needs ink. Okay. Besides generic value, there is a very important type of, does Tom write? Again, the answer is not in the description of Tom. Whatever we had described for Tom, it was not there in through which hand he writes. It was not there, right? So, what can we do? We suppose in the description of boy, we have another slot writes with right hand. Now, I have put a star here to show that this value is a different type of value. What is that? That in general, that is, unless anything is known to the contrary, I will assume that a boy writes with right hand, but it may not be true. So, this type of values which we assume, since we are not told that Tom is left handed, we will assume that Tom writes with right hand. This is known as the default value that we assume in the absence of any more information. Now, again you can see that the default is with right hand, but if in the there is a difference between generic values and default values. If while describing Tom, I get some additional information that Tom is left handed, obviously the default value will be overwritten. However, the generic values cannot be overwritten. If it is overwritten, the generic values are tightly connected to the class. If the generic value is changed, then the class definition changes. Okay. Now, so we see that inheritance is a very powerful mechanism, and I will briefly talk about inheritance because we have seen inheritance so many times in semantic nets. The known values can be inherited from the parents unless more specific information is available with the child. That is, in the superclass or the parent, the generic values and the default values are specified in the superclass. The generic values are retained and the default values may be overwritten, that we have already said. One issue is there which is little difficult to solve, multiple inheritance. That is, a class or an instance may be a child of multiple parents. Now, what to inherit? For example, say I define a class teacher politician. A teacher politician is a teacher as well as a politician. Now, for a teacher, the top priority is quality education, whereas for a politician the top priority is a vote bank. Now, I say Mr. X is a teacher politician. So, what is the top priority of Mr. X? It is very difficult to say, and there we have to take some policy that depending on the context we may decide which property, which parent's property will inherit. Okay. Now, similarly, you can see here is another example, scooter. I can say it is automobile and two-wheeler, and two-wheelers have number of wheels 2, automobile has wheels 4. So, if I say scooter, then how many wheels does scooter have? But this is a wrong organization. This problem should not have occurred. The correct organization should have been this: automobile, two-wheeler is a automobile, scooter is a two-wheeler. In that case, when I try to answer the query, this how many wheels does scooter have, I will go to the top, the first one, and try to inherit this. So, what is the inference mechanism in frames? The inference mechanism is simple. Look for a candidate frame or instances, look for the availability of values. If the value is available, then it is solved, else go to the preceding level and so on. If solved at a higher level, try to have a more specific answer. Now, I will just illustrate this with this. Say, suppose how many wheels does scooter have? I do not find that value as an attribute, but since I do not specify everything everywhere, I go up one level and find that two-wheeler, scooter is a two-wheeler and it has got 2 wheels. Therefore, I infer by inheritance that scooter has 2 wheels. If this was not specified, I would have gone one level higher and would have taken the next the higher level information inferencing. However, this is just to give you an overview of frames. There are some subtleties in frame based system. So these are very important in answering queries. For example, say with which hand does Virendra Sehwag bat? Now, Sehwag has been described with a batting average value. That attribute is here. Now, Sehwag is the opener. Well, but here I do not have anything saying with which hand he bats. I go up because opener is a batsman. I go up, and in batsman, say there is a default value specified that he is right handed. I can specify that Sehwag is right handed. In the same way, frames can also be used for classification of objects, and there are many other applications. But for this lecture, I think this is sufficient, and I would encourage you to describe different scenarios like cars, automobiles, or the objects that you see around you, and try to make a frame based representation, and also utilize the examples that have been given them into frames.